Okay, section 2.3 is polynomial long division. Before we do polynomial long division though, let's just review some basic long division. So like, let's say that we wanted to divide 20 by 6. Okay, that's the same thing as 20, the fraction 20 over 6, right? Or to set up for long division, we would do 6 dividing into 20. And we go, okay, well, 6 doesn't divide into 2, right? 2 is smaller than 6, so 6 doesn't divide into 2. So then we move over and we go, okay, how many times does 6 go into 20 or divide into 20? And that would be 3 times. And then we do 3 times 6 would give us 18. We subtract, and we'll get 2. 6 does not divide into 2, so 2 ends up being our remainder. Okay, so that means that another way that we can write 20 over 6 is as a mixed number, right? So that would be 3, and then we put our remainder of 2 over 6, right? That's the same thing as 3 plus 2/6, but for mixed numbers, we don't write the plus. And then the 2/6, you guys know, divides or simplifies to be 1/3. And again, so 3 1/3, remember, would be the same as 3 plus 1/3. So we could say that 6 times 3 plus 1/3, okay, would be equal to, if we distribute, think about it, that would be 18 plus 2, which is 20. Let's do another example. Let me make some room here. Okay, so let's say that we wanted to figure out what 2,618 divided by 7 was. Okay, so setting up for long division, we'll go, okay, 7 does not divide into 2, so we'll move over and go, 7 goes into 26 how many times? That would be 3 times. So we do 3 times 7 would give us 21, and we subtract. We can bring down the 1, and 7 divides into 51 7 times, and then 7 times 7 would give us 49. And when we subtract, we'll get 2, and we can bring that 8 down. And then now 7 divides evenly into 28 4 times. 4 times 7 is 28. And we can see that we end up with a remainder of 0. Okay, so 2,618 divided by 7 is equal to 374. Or an equivalent statement would be 2,618 is equal to 374 times 7. So we're going to use a similar process for polynomial long division, and we're going to start with an example where we already know the answer. So since you guys know that x squared plus 4x minus 5 factors to be x plus 5 times x minus 1, its equivalent statement would be this, right? X squared plus 4x minus 5 divided by x minus 1 has to be equal to x plus 5. And we'll just prove that using polynomial long division. So setting up, we're dividing x minus 1 into x squared plus 4x minus 5. And it's going to feel like a similar process to when we did long division up here. So we'll go, okay, what times x would give us x squared? Or that's the same thing as x squared divided by x gives us x. And then we multiply x times the quantity x minus 1. So you're thinking of using distributive property, and you would get x squared minus x. I like to put parentheses to remind me that I'm subtracting that entire quantity. X squared minus x squared is 0. 4x minus negative x would give me 5x. And now I can bring the minus 5 down. So now I will think what times x would give me 5x, or same thing, 5x divided by x would just be 5. And I can multiply. And when I subtract, I see that I get a remainder of 0, which is what I was expecting here. Since I know that x plus 5 times x minus 1 equals to x squared plus 4x minus 5, I know that x minus 1 divides into x squared plus 4x minus 5 evenly. So I would be expecting a remainder of 0. So in general, when a polynomial is divided by another polynomial, we can express the result in the following form. So p of x, remember these are polynomials, so p of x divided by d of x will equal to q of x plus r of x over d of x. And p of x is the dividend. D of x is the divisor. Q of x is the quotient. And r of x is the remainder. Now think about if we took that equation and multiplied both sides by d of x. We would get p of x equals to, distributing d of x, that would be q of x times d of x plus r of x. So you can imagine if r of x is equal to 0, right? So if r of x weren't there, then q of x times d of x would be equal to p of x. Meaning q of x and d of x would be factors of p of x. All right, so let's practice some polynomial long division. So we are going to divide this long polynomial, cubic polynomial, by 4x plus 5. So 4x plus 5 is our divisor, and 4x cubed plus 13x squared minus 2x minus 15 is our dividend. So we think, what times 4x would give us 4x cubed? Remember, that's the same thing as 4x cubed divided by 4x. So we get x squared. And then we think about multiplying the quantity 4x plus 5 by x squared. So think distributive property. And then subtracting, we will get 8x squared, and then we'll bring down the minus 2x. So just like you would bring down the next digit, I'm bringing down the next term. And think, what times 4x would give me 8x squared? So that would be plus 2x. And then multiply. And subtract. Same process as normal long division. Subtracting, I get minus 12x, and then I can bring down the last term, the minus 15. And I think, what times 4x would give me negative 12x? That will be minus 3. and then I multiply. And in this case, we get a remainder of 0, which means that 4x cubed plus 13x squared minus 2x minus 15 divided by 4x plus 5 is equal to x squared plus 2x minus 3. Just as a little bit of a bonus, or thinking towards what we're going to be doing later in this chapter, if we were to multiply both sides of this equation by 4x plus 5, wouldn't we get 4x cubed plus 13x squared minus 2x minus 15 is equal to 4x plus 5 times x squared plus 2x minus 3? Which we could even go one step further and think about factoring x squared plus 2x minus 3. Okay, so then now we have factored this yucky looking polynomial into, as far as we can, into linear factors. All right, let's do this next one. So we are dividing 2x cubed plus x squared minus 4x minus 3 by x minus 1. So get that set up. And we think what times x would give us 2x cubed, and that would be 2x squared. We can multiply. And subtract. Bring the next term down. And we'll think what times x would give us 3x squared. So multiply. And we get 7x and can bring down the minus 3. And then what times x would give us 7x. Once you get the constant, you're done. So remember to finish multiplying. And when I subtract, I get 4. Okay. So 4 is going to be the remainder. So how I can write my answer is that 2x cubed plus x squared minus 4x minus 3 divided by x minus 1 equals to 2x squared plus 3x plus 7, and then plus the remainder over the divisor. And we're done. Okay. So now we're going to divide this quintic by this cubic. Notice that there are terms missing in each of these polynomials. Like the quintic, it does not have an x to the fourth term, x cubed, or an x. And then the cubic is missing an x squared term. So I'm going to use placeholders just so I don't make any mistakes. Okay, so all the terms that have a coefficient of 0, they're just placeholders. Okay, so I think what times x cubed would give me 2x to the 5th, and that'll be 2x squared. And I can multiply. And then subtract. Okay, and then notice that everything is nicely lined up. When I use my placeholders, I can actually bring the plus 12 down now as well. So I go, okay, what times x cubed would give me 6x cubed, which is the same as 6x cubed divided by x cubed. So that'll just be plus 6. And then I can multiply. So I'll be left with 11x squared plus 18x plus 36. And then notice that when I go, okay, what times x cubed would give me 11x squared? Well, x cubed has a larger exponent than x squared. And polynomials have to have whole number exponents, so we are done. So this would be the remainder. So I can write this as 2x to the 5th plus 3x squared plus 12 divided by x cubed minus 3x minus 4 is equal to 2x squared plus 6 plus 11x squared. This is the remainder part, which I am putting over the divisor. So this represents this. Think of it like we rewrite polynomials in factored form. This is how we are rewriting that ratio in an equivalent form. So this is kind of looking towards the future. We're not using this quite yet, but in section 2.6 we will. All right, synthetic division. So synthetic division is a nice little shortcut for a special case. So that special case is when the divisor is in the form x minus a or x plus a. So not a number times x minus a or a number times x plus a. It has to be x where the coefficient on the x is 1. Plus or minus a constant. And so whenever your divisor is in that form, you can use synthetic division because it is a contrived shorthand way of dividing a polynomial by a linear factor. All right, so to do synthetic division, I'm going to make, there's different notations. I do this like kind of half a box. And then up in this top left-hand corner, I'm going to put what the value that would make the divisor here equal to 0. Because remember, this can be thought of as x minus -1, same thing. So I'm going to put -1 up there. So the value that would make that factor equal, or sorry, that divisor equal to 0, I'm going to put there. And then I'm going to put all of the coefficients for the dividend. So that would be 1, -1. Don't forget, if you're missing a term, to put a placeholder to 0, -2, 2. And then what we're going to do now is bring the 1 down, and then we go 1 times -1 would be -1. And now we add straight down and get -2, and we'll do -2 times -1 is 2. And we add straight down to get 2. 2 times -1 would be -2. We add straight down. And then -4 times -1 would be 4. And then we add straight down and we'll get 6. And this last column is always going to be the remainder. Okay. So what this says is that x to the 4th minus x cubed minus 2x plus 2 divided by x plus 1 is equal to, okay, these are just the coefficients now of the quotient. So that is x squared minus 2x, or sorry, not x squared. That would be x cubed minus 2x squared plus 2x minus 4. And then my remainder is 6, so I'm going to put 6 over the divisor. And that's my final answer. So it's just, synthetic division is kind of a faster, shortcut way of doing polynomial long division, but it only works when your divisor is in the form x minus a number or x plus a number. All right, let's try this next one. We can use it since our divisor is x minus 1. Okay, I make my kind of half box. I'm putting 1, because 1 would make my divisor equal to 0. And then I'm putting all the coefficients of my dividend. Okay, remember the last column is going to be the remainder. So we bring 2 down. 2 times 1 is 2. Add straight down. 2 times 1 is 2. Add straight down. 1 times 1 is 1. Add straight down. So it looks like we get a remainder of 4. So 2x cubed minus x plus 3 divided by x minus 1 equals 2x squared plus 2x plus 1. And then I'm going to put my remainder over my divisor. And we're done. So again, we can use synthetic division because of our divisor. I'll put -2 in that top left corner. Put the coefficients. Don't forget zeros for the terms that aren't there. You can think of them as having coefficients of 0. Three times -2 is -2, or sorry, -6. Add straight down. Add straight down. Add straight down. It is 19 times 2. Be 38. Okay, add straight down. And 38 times -2 would be -76. So -83. So So 3x to the fifth minus 2x cubed plus x squared minus 7 divided by x plus 2 is equal to 3x to the fourth minus 6x cubed plus 10x squared minus 19x plus 38, right? This will always be the constant. And then our remainder is minus 83, so I'm going to put the 83 over the divisor. Remember, that's the same thing as plus and negative 83 over x plus 2. Either one works. Okay, so that's polynomial long division, and then also synthetic division as a little bit of a shortcut for polynomial long division.